All right, cool. I can see it now. So talk title, keywords mess. I think the keywords shouldn't be plural, should be keyword
wait,
mess.
hold on a second. We just see the infinity. Wrong display.
Yeah, no, I know. I haven't switched back to the code yet. Anyways, so there's two games I'd like to play with you as we go. First of all, the code has seemingly lots of errors. That's just my IDE. But I'm trying to say, don't trust the IDE that it tells you everything here works. This may or may not compile. So I guess I'm challenging you to, at the end of the talk, to tell me if this whole thing compiles or not. The second thing is that I want you to count every non-keyword, such as this be or that, and non-label and non-macro until the end of the file. And those who get it right will win my appreciation for paying attention. All right. So this was just me having fun the other day and try to mash in as many keywords together. So this is pretty simple. Const static inline. I think everyone knows we can do this. Not, but it's more like not static cast, false. And then you can use not as a function. Funny enough, you cannot use operator not. This doesn't work. We have a template. The concept doesn't have to accept any parameter, but it does have to have an expression or something inside of it. So this wouldn't compile, I'm telling you, but this should. Okay. Have a export struct b virtual const volatile void is just a regular class. We have a constexpr struct, for those who know what that is. And then you can also const and extern and inline on that struct. And it inherits from B. We're also aligning it as some union. Okay, so here we get to the fun part. We have a template with a requires clause, and it's marked const eval and inline and auto, and function's name is f, and it takes in. And now you don't know if this is a variable name or if this is actually a reference. So that's something you have to think about. It's also marked const and no except. It's both. It's a try function with a constexpr register is apparently still a keyword. And then we're returning delete of a new double. So far, so good, hopefully, if you're not lost yet. This is just a regular function, constexpr static inline with the const init now. Think about what would happen if I remove the static here. And then I'm initializing it to, and this is either an int or a std initializer list. Your choice. We have a std generator, and then we're accessing a co-yield operator, new, of a size of a line of a null putter, trying to use every keyword in the standard co-return. For some reason, I don't think you can return an expression here. You need to just return, and that's it. Don't understand how that works. At the end, we have a virtual const volatile void with some function that takes in, that is actually marked const now except override final. I think Jason Turner will tell you that you should either mark a function virtual or override or final. Don't do more than one. This is fun now. For infinite loop, if constexpr, this is whatever. But this is the fun part. Do while of a const eval. Const eval has to have braces after it. Does the else need braces or not? Think about that. Have a while. Now, is this a while loop, or is it attached to this do while, or is this do while here done? Is that an error? Do you need a semicolon here? Think about that. Some other do whiles apparently. If long short switch case colon semicolon else, and then 3 while trues. And one of these could attach to this upper do. Okay. I think I'm almost out of time. We'll have operator auto. You can do that for some reason with a label switch on hexadecimal, unsigned long literal. This is all fine. You can take an address. This is taking an address of a label, reinterpreting it, and then dereferencing it and returning that from this auto. I don't know how we're ever going to trigger this operator. This is just some type name. That's fine. Explicit operator volatile void. Apparently that's fine. It's also marked volatile, but it's deleted. Lastly, we have the spaceship operator, and then some mutable enum, and then just a tiny little bit s here. Without this, the constexpr at the top wouldn't work. So there you go. So at the end of this, place your bets. Do you think this is going to compile or not? And how many variable names, or names in general, non-enables, non-macro, non-keyword, are there in the whole thing? So does anyone want to take a guess? Can we unmute? Or a poll? Who thinks this is going to compile?
Hold on, we're going to unmute the room.
Okay. If you think this fails to compile or is going to compile, mark your case.
There's no way I'm going to know. Can you hear us?
Yeah, I can hear you barely. You need to shout.
All right, anyone who wants to join in here, go for it. And then we're out of time.
All right. If you think it's going to compile, raise your hand. I guess that's the easiest way of doing it. I see a couple hands up. Okay. If you didn't think this is not going to compile, raise your hand. Is there anyone who thinks it's not going to compile?
Yeah, there's the other side of the room doesn't think I'll compile.
Okay. So Compiler Explorer says this does compile with a couple of warnings, but it does. Crazy enough. How many variable names are there?
All right, you're out of time. Sorry.
Just one last guess. I'll tell you. I counted 24. There's probably more. I'll post the Compiler Explorer link on the Discord. Thank you very much.
So my talk is called, no, I'm not going to do all that again. So let's talk a little bit about floating point. Who remembers encountering floating point error for the first time? I remember mine. It sucks, right? Like it's brutal. You don't have any understanding of what's going on. It seems like this thing that you've been promised has just completely broken down. And then you fall down the rabbit hole and you have to learn about like what happens with this at the binary level. So like, can anyone list off the parts of a floating point number according to IEEE 754? Yeah. Yeah. One more. Yep. So we got a mantissa, we've got a sign, and we've got an exponent. The sign is pretty apparent. It's one bit. That bit's simple. The rest of it sort of sucks. Who can tell me, let's say a 32-bit floating point, how is the exponent stored?
It's like the power of 2, but with an offset of like 128 or something?
127, very strangely. So if you have 1 bit set in it, you actually are at 2. Try not to think too hard about it. How about the mantissa? How does that get stored?
That's the first bit is implicit.
There's an implied 1 that gets added to whatever value you have, and then each bit represents something. Can anyone tell me what it is? It's each bit is an additional half from the so the first bit is half, and then the bit after that is a quarter, and if you have them both, you've got 3/4. And so you kind of do this limit with the mantissa where you're between 1 and 2. Sort of, yeah. But as like fractional representation. And then can anyone tell me how we combine these? Yeah. Well, no, but like the mathematical formula that we use, we've got an exponent, we've got a mantissa. How do we put them together? So you take 2, you put it to the power of your exponent, which has an implicit shift in it. You multiply that by the mantissa, which you've added 1 to, and then multiply that by 1 or -1 for your sign. Who thinks that's intuitive? All right, so let's talk about float at an intuitive level. Who feels like they have a good intuition for floating point? All right, Chris, you're volunteered. For a 32-bit float, the number represented in my exponent is 132 decimal. What is my exponent? That was enough. Okay, it's 5, right? So the number you have is 5 because you subtract 127. What's 2 to the 5th? For the same number, the mantissa is whatever that is. I'm not even going to bother trying to say it. 2 million, whatever. What number is your mantissa? I'll tell you that in hexadecimal, it's 280000, 4 zeros. So
1.5.
I'll tell you it's 1.3125 when you factor this in. So what is my floating point value? What value is this floating point representing? No one? Simple math. We landed on everyone's favorite number, 42. I was surprised no one guessed that, actually, just kind of by rough approximation. This is what we're teaching beginners. Does this make any sense at all? All right, so let's talk about floating point at the binary level. Or sorry, fixed point. It's literally an int and a power of 10. What?
1 minute.
1 minute left?
Yes.
Okay. Let's talk about this at an intuitive level, right? I need another volunteer. I promise to be nicer. Ben, you have an int that's 4,200 and a power of 100. What value do you have? Yes. It's 42 again.
Yeah.
Wow, that was way easier, right? So like, why are we doing this? Right? Like, why are we doing this to people? And I think the answer to this is like, there's a simplicity in floating point that you get a large range of values, and on its face, it kind of hides a lot of the complexity, but only for a brief period of time. And I think it would be better if instead of leading off with floating point and then letting people get like hurt by it later, if we let off with fixed point and we're like, hey, like we can't represent infinite precision. Think about the trade-off that you're making here. Select that trade-off.
Time.
Anyways.
There we are.
All right,
Fantastic.
start.
All right.
Let's go.
So my best bug, back when I was interviewing people, particularly for senior positions, one of the questions I would ask at some point is, tell me about the best bug you've ever seen or been a part of, or worst, depending on your point of view. What I'm really after is the war story, right? If you're an experienced developer, you should have war stories. So this is mine, and it is even more relevant because it's exactly related to something that Jason's been telling us about a lot recently. So back in the day, this is early mid-2000s. Dan was there. You were around at the time, I think, at a place called Numerica. We were doing a ton of linear algebra, lots and lots of linear algebra. And we had an in-house linear algebra library that had been built by a bunch of basically math grad students. And one of the things about our vectors and matrices is we needed the equivalent of a NaN, right? Something to say, the result of your computation is nonsense, you don't have an answer. So our thing had an is valid, right? That's easy enough. But the other thing we did, remember, this is early mid-2000s, no unit tests, none of this stuff at the time. We gave it a conversion to bool that was implicit. I'm not even sure we had the explicit keyword at the time, or maybe we didn't know about it. But IO streams do this, right? Like C in, C out, F streams have an implicit conversion to bool, which is very nice syntactically, and we liked it. So, the syntax, you do some computation with your matrix, and you just say, if my thing, and then it's good, you do your thing. Or if not my thing, you got an error. So, if IO streams are in the standard library and they must be well designed, that's a joke. Never mind. Why can't we do it too? So the plot thickens. So we're doing, this was some experimental motion model for a Kalman filter. Never mind the details, all those bold capital letters are matrices. In code, that's H dot times T times P times H transpose plus D over 2. Right? How easy, this is right? Why is there a problem? But here's the thing. This was part of an algorithm that was basically combinatorial time in the size of the input. We needed every clock cycle we could get. So the fact that multiplication is faster than division was something we were trying to take advantage of. So we wanted to change this during some optimization, trying to make it run faster, right? Instead of dividing by 2, multiply by 0.5, right? Speeds things up. Some tiny, tiny little bit back in the day. So we wanted to make this transformation to try to speed things up. But we goofed, and somebody fat-fingered it. Might have been me, I don't know. We actually typed that.
Oops.
Now, this shouldn't compile. You can't divide a scalar by a matrix, and we didn't put that in our classes, so this shouldn't compile, right? I mean, that operation doesn't exist, but this one does. You can divide doubles by ints, and Booleans promote to ints, and we have an explicit conversion to Boolean. So this, because our compiler is helpful, this is what Jason's been talking about recently, turns into, well, we compute D, or we've got D, it's valid, the Boolean version of that is 1, which promotes to an int, and that turns into 0.5. But you can't add scalars and matrices, so this should still not compile, except now you know where we're going. So it would compute at some cost all this other business. It's a valid thing, and this whole thing would turn into 1.5. Now, but wait a minute, this is supposed to be about H, P, H transpose supposed to be over to, that's a matrix. How do you not notice that you don't have a matrix anymore? Answer, it's part of some even bigger horrible computation. We're really computing that K matrix there. And if the answer isn't actually a matrix when you get to that point, if it's really 1.5, that compiles and that runs, and we had no clue. Until we started writing unit tests and realized, oh, we wondered why that motion model never seemed to work out very well. So, morals of the story, implicit conversions are a problem. Thank you, Jason. Implicit conversion to bools are spectacularly horrendous because bools convert to everything. Don't do this. And write your damned unit tests. Homework, exercise for the reader. It's a bad idea for these to have explicit conversion to bool. Why is it okay for IO streams? I'll let you go ponder that. Thank you.
Start.
So this is pretty short, but C++ is unique. I always find it just fascinating how it developed different than everything else. So I'm going to start with some prehistory. A long time ago, there were two intrepid explorers, and they did some amazing things at an amazing place, but they were being chased down. And they needed a plucky, roguish hero to help them. Which leads to the, I want to convince you that the C++ is the Millennium Falcon of languages. Hello and welcome to my TED Talk. So this is in 1972, Dr. Gene Samet wrote a book on programming languages. And so this goes up till 1972, and this is sort of the state of programming languages for applications. You have a question? Oh. Yeah, so it is like the definitive of like what a language is and how it does it, and the reasons for them. So there's all these different categories. C is not there. You'd think, well, C is a language, right? But she has a specific mention of things that are excluded from application programming languages. She's not talking about systems programs. And C is systems programming language. So why are you guys all writing applications in a systems language? You're doing it wrong, right? So there are things that systems languages need that nothing else has. If I go back in here, every one of these languages is afraid of it. They hide it. They don't want people touching it. Anyone want to guess what it is? Yes, pointers. So when you're a systems language, you are dealing with the low-level code. You are dealing with the processor itself. So that is a fundamental option. We are using random access memory. So you have multiple instruction pointers. You have data pointers. Those are all things you have to use. So when they made C, you have to have it in there. And so C++ carries it along. And I think that makes it fascinating as an application language. We still get this. So yeah, going back into here and to this day, moving on, people don't want you touching pointers, but we have it. And when we say that you can choose your own abstraction, it's because there is nothing between you and the underlying system. So I don't think anyone writes hardware that does cellular autonoma or combinatory logic as its underlying system. We are a random access, which is kind of a Turing machine, right? Just multiple tapes. So it may not look like much, but it's got it where it counts. So with my analogy, that also means Stepanov is Chewbacca. And that's it. So thank you.
Hi, good evening. My talk is called The Cross-Section of Programming Practices. So what do I mean?
Practices are just any action that we take to make computer programs. They come in a lot of forms, but importantly, they all serve the same goal, is that we're trying to make software. So here's a couple of them, but there's a ton, and there's probably even more in later slides than that I didn't even list. But quick detour. Anyone recognize this chart? Yeah, it's the way the different Pokemon types attack each other. So for example, fire does double damage to water, which kind of makes them intuitive, or other way around. Water does double damage to fire. Fire does double damage to grass, and so on. So if you notice, the left and the top, they have the same items, and they're going in the same order. So if you look at one row and one column, you can see the way that the left column attacks whatever is in, you can see what's type in the row attacks whatever type is in the column. And you can see whether it does more or less damage, or just neutral. So it's a sparse graph. Most interactions.
Hardly anyone here. I was just come by to check to see if you still had Black Friday sales.
So we can actually do the same thing with all the different ways, all the different things we do to make software.
What's that?
So if you look down all the rows, there's a bunch of different software practices.
Okay.
I listed a bunch. There's even more, I'm sure, that we could list on here and make the table even bigger. But I just want to look at this for a little bit. So to read this, take any given row, line it up with any given column, and you're going to see how two different programming practices interact with each other. So typically when you combine them, there's going to be some effect, either positive, potentially negative, or neutral, and a lot of effects. So to read the graph, the light squares are a somewhat positive relationship between the two practices. A dark green square is going to be a strongly positive relationship between the two squares. So for example, if you look at debuggers, you can go to the debuggers row, and we're going to compare that with automated tests. So that's the third column, and see that's a dark green square. So what it means there is that the combination of a debugger in your programming practices with automated tests is strongly positive. Why is that? Well, it's because your tests give you entry points for the debugging session. If there's a given piece of code you want to debug and you have a broad test suite, chances are that code is already covered. And there's one, if not many, entry points into that section of code for you to actually debug. Entry points that have different preconditions, that test different cases. So when you combine having the infrastructure set up to easily run a debugger, not just that you have one installed, but that you have the means to actually run it, the experience to run it, everyone on your team is familiar with it and comfortable using it. If you have a broad set of tests, those two interact very positively. Conversely, we can look at one of these null relationships, like an auto formatter plus standard plus static analysis. That's the second column, is really no interaction. One tool doesn't allow you to get more value out of the other. And you'll notice that for most of the chart, it's rather sparse. But there's a few observations from this. So most things don't interact with most things. If you add a new tool to your organization's tool belt of practices, chances are it won't help most other things, but everything interacts with something. So no matter what tool you're adding to your suite of practices, some other practice, which you may or may not currently be using, is going to benefit from that. So a big takeaway from this is the more practices you employ, the more you reap all these cross-sectional benefits. So I listed every item that I listed on this slide. These are all things that I try to do in my organizations or my personal work. So I certainly reap the benefits. So for a couple of specific ones, automated tooling plus CI is awesome. If you can automate how you do something, how you analyze your code or anything like that, you can run it in CI. You can't really do manual things in CI. Tests and sanitizers are also awesome. If you have sanitizers enabled, you have to run code for the sanitizers to actually work. They're not static tools, they're dynamic tools. So the more that you can run your code, the faster you can run it, the more you get from that. And then also, anything that scales well with headcount works really well with LLMs. So if you look at the bottom two rows, they're pretty similar. The things that benefit LLMs also benefit from more headcount. So if you're someone in an organization who you're very gung-ho on using AI, maybe you should do all these other things. All these other conventional practices are actually really good. And with the last few seconds, here's some more things. I would love to expand the table, but not enough time for that.
Thank you.
Okay, so something I find myself doing quite often is teaching people more things about Git. And this talk kind of falls out of that because I'm annoyed with people's lack of like fundamental understanding of what Git is. And I think if you have a decent understanding of what Git is and how it works, a lot of the like mysterious things that seem to happen with Git will stop happening to you. So before we launch into this, who has ever gotten so stuck with something that happened with Git that they just deleted the whole clone of the repo and recloned it? Yeah, that's like nearly every hand. Did you ever figure out what happened with it?
Yeah.
So like, we got one yes and the rest no's. I find that if you can understand what Git's doing under the hood, a lot of these mysteries sort of evaporate, or you can explain them to yourselves and at least understand how you got in that situation, and then probably not get in it again. So let's start at the bottom here, right? Like, what is a commit exactly? It holds code. It's got your commit note. It's got some like the author, some other metadata about when the commit was written, and then crucially, it has the hash of the parent, right? And then that commit gets assigned a unique identifier, which is the hash of all of those fields. And how that all works, don't worry about it. It's complicated. It's implementation details. We can compose commits, right? We have that parent hash. We set it. That's our. It has a unique identifier to the parent commit has a unique identifier. We set the parent hash. We're done. Commits can have multiple parents. This is how merges work. And then, like, interestingly, there's it's like a directional graph. It's like a unidirectional graph. There's no trivial way to find all of the children of a particular commit. You can only go in the parent direction. Children finding is like graph traversal algorithms. You can do it. It's not horrible, but it's not easy. So like, then what causes your SHA to change, right? I think this is where a lot of people kind of get stuck and get confused. So when any of the data in your commit changes, that changes. So if you change the code and you amend the commit, you're going to have a new hash. But that also includes the SHA of the parent, right? So if any of the parents' data changes, then the data in your commit is also going to change. So if any of the data in any of the parent commits change, all of the downstream SHAs will change. And you'll end up with a completely unrelated set of changes that are only kind of related morally, which is how a rebase works, right? This is exactly what a rebase does. It says, hey, I want to go change something, maybe a parent commit, maybe the contents of a commit in the history, maybe I want to change what it's based on, and then everything downstream of that has to change. This fundamentally is like the whole model for Git. This is how it works. And if you think about things from these first principles, I think you will be less confused most of the time. That's all.
All right, I'm going to talk about this because I saw reflection in C++ 26 and I was very excited. But then I found out that it didn't cover expressions and statements, so I was a little disappointed at that. I guess it's deferred is the word they used for that. So I looked around for some other way to do that, and I found CPP2, so I'm going to talk about that for less than 5 minutes now. So before I do that, I'm going to talk about Lisp macros because it's relevant. If you don't know Lisp, that's okay. The point of it is that Lisp code is just a big data structure. And because it's a data structure, you can just edit the data structure and come up with like different code, right? And this seems like a fundamental aspect that languages should have, but C++ really doesn't have this unless you like work in the compiler itself. So this is the basis of Lisp macros that are used in most, if not all, Lisps. And I thought it was really cool, and I always liked, writing macros and stuff. But C++ doesn't have it, so I tried to find something, and the closest thing I could find was CPP2, which is this experimental version of C++ that Herb Sutter sort of uses for like trying weird features or researching things about C++. The point is that it's compatible. It basically transpiles into C++, sort of like in the old days, C++ actually transpiled into C and then got compiled up by a C compiler. But here, you transpile to C++ and compile it with your C++ compiler. And the idea here is that it gives you reflection of statements and expressions, which is really what I was looking for. Unfortunately, it doesn't work as well as Lisp does, which I was unhappy to find out. You do get the statements, you get C++ statements, but you can't directly edit the data structure. You can add statements, but you can't remove them. And in general, and you can't apply them directly to functions. You can only apply them directly to types, which then you can look at all the functions inside the type and sort of mess around with those. So it's not quite what I wanted, but it's good enough for me to do some stuff. So here's a real quick example of this is CPP2 code. I mean, it basically looks like C++-ish. The main thing that we're going to do here is we're going to try and generate the code that's behind the comments. And if you look at it, you can see that it's mostly like the function above it, except the name has a 2 at the end. And any function calls to A are replaced by function calls to B. So that's all I'm going to do. So I have a meta function called rewrite A to B, and I have a little ampersand. You can see that in the type definition. I'm going to say apply the meta function rewrite A to B to this type, and that meta function will then add this meta generated function. So here's some code. Unfortunately, I can't, when I get a data structure representing the code, I can't like make a new data structure and return that. I actually return a big string of code that then gets parsed and compiled. So that's a little disappointing as well. But you can see here, I just added 2 on the function name. And then I go through all the statements in the function. And if I find any statement that's a function called to A, I just replace the A with a B and then use that as my statement. Otherwise, I keep the statement unchanged in my new code. And then I add a curly brace at the end, and that's my new function. So that's pretty straightforward. Took me a while to figure out all this stuff because I was expecting to write like a Lisp macro, but in C++. But instead, you kind of have to do a little more work than I expected. So there's a bunch of possibilities here. A lot of people ask me, why would you want to do this? And some of the obvious things are to basically add extra annotations to your code. There's actually a meta function called noisy that adds a print statement at the beginning of every function that says it's entering that function. I kind of want to try it for model checking, which is to take the C++ code and generate a finite state machine or a transition system that you can then analyze using other mathematical tools. 1 minute. More sophisticated function instantiation. So a lot of template meta programming would go away if you could actually use meta functions freely. And then the key one that I think was shown at CPPCon was autodiff. And that basically takes the function that generates a mathematical function from X to Y, and it rewrites the code so that in a second function that produces the derivative. So if you have a C function that computes 3x squared, autodiff will generate another function that is 6x, right? It'll actually just generate the C code for you automatically, which would be handy because then you don't have to do it manually by hand. And then there's other different kinds of generators that you could write that would be better if they were done by a compiler and not by a human. And that's it.
Great. So I'm going to be talking about some reflections on integrating generative AI to help upgrade a build system in a legacy code base. So I work in medical devices, and in our department, we've been around 30 plus years. I haven't. People have. A lot of core algorithms and core components were first written actually in the early 2000s. And since we're in such a highly regulated environment, it is very difficult to introduce modernization into it, clearly, because anytime you touch a line of code, then it opens up a huge can of worms on whether you should, do you need to apply it to already released products, etc. And once in a blue moon, we get opportunities to refactor and to make things better. And we got one of those a little while ago. Show of hands here. Has anyone in the room worked with Boost Jam or BJam? There's a few hands. Awesome. Keep your hand up if you still use it. None of the hands are still up. Was it popular? Was it ever? I don't know. But it's not very well documented. It's not maintained. And so this was a pain point in our development, for developers forever, at least since I've been there. Especially since CMake gained popularity and is a lot better supported. So we had one developer take initiative about 3 years ago, just 3 years ago, to transition our code base to using CMake instead. And it resulted in massive improvements for compiling our whole, our whole system. Thank you. James Arms is the name here, who was the savior there. But doing that conversion was not straightforward. Parts of it were like you start off with a jam file that you are then, essentially just transcribing over to be a CMake list. And he said that first step there of just doing that translation took about 20 minutes per file, some more, some less. So even just doing that across the 120 subdirectories that needed it would be about 40 hours on its own. And this was great, huge improvements for the developer experience, but that's not all of the applications that needed that update, and reference back to other services that had the update. So we discovered that it would be best if we updated these supporting applications too. But that meant that we had to go back to that really tedious step of doing that transcription from jam file to CMake list.txt. And for just this support app 1, we knew we had to do it 50 more times. That would be about 16 hours by hand. And in fact, there are a bunch more support applications we're going to need to do this for. So I started thinking, what kind of tool can we make to make this easier, to reduce headaches? And I asked the very dangerous question, can we use AI? Should we use AI? It's another question here. And of course, my work has a chatbot now. We also have an isolated instance that you can also, if you ask enough questions, you can, if you ask enough questions, you can get API keys to customize your own LLMs here. And I thought this was a well-suited use case for getting generative AI involved, because it's a simple acceptance criteria. Does it build or not? We're working with well-documented technologies. We've got examples from the code base that we can use as gold standard here. And this is so mundane. No one wants to do this. We kicked the can down the road for 4 years on this thing to do these updates for the supporting applications. So that's why generative AI is what I turn to. So yes, we can use AI for this, but with some caveats that I found it really useful for the first drafts here. The tool that I made tackled all 50 of those in 5 minutes. And to do that, it did require some iterative prompting and other prompt engineering skills. For example, setting the system message to say, you're an expert in C++, build systems, compilers, etc. Wouldn't it be nice if you could just wake up in the morning, say that, and then it just happens? Thankfully for the LLMs, you can do that more or less. Another challenge I had to overcome is that AI is inherently non-deterministic. You gave it the same input 4 times, you're going to get 4 separate outputs. So there were some tools that I could use in order to drive that consistency forwards there. And this goes without saying, you've got to check the quality of the files being output. Is what you're generating hot trash? Yes, a lot of the time, yes. But if you have enough safeguards in place, if you have enough instructions to get that consistency there, then it can actually be meaningful. Also, make sure there are some humans in the loop somewhere. I had subject matter experts review this, integrate it with tooling, make sure you're doing code reviews. But the big takeaways here is that I found spinning up an LLM to help with this transition extremely useful. It saved me hours, and it saved other teams hours who are approaching the other supporting applications too. AI did not magically solve the problem on its own, but yeah, make sure that you are taking responsibility for the output of your AI tools, but it's still useful when you use it right. Thanks.
Thank you.
All right. My name is Phil Barila, and I'm going to talk about how to navigate imposter syndrome. Sorry about touching the mic, guys. Okay, so what is imposter syndrome, and does it really exist? And why am I talking about it? And how do we deal with it if it does exist? Okay. Imposter syndrome is feelings of inadequacy or disqualification from the position or role that you hold. And I have some examples of thoughts that may occur, and you probably have a few you could fill in yourselves. So, is it really a thing? Well, even though they didn't use the term imposter syndrome, several very famously capable people expressed ideas that are consistent with imposter syndrome. Isaac Newton, wanting to be Jesus Christ or like Jesus Christ and finding himself falling very short. Albert Einstein compared himself to Isaac Newton and found himself lacking greatly. And a recent Nobel winner said he felt unworthy to be in the same universe with Albert Einstein, much less on the same list of prize winners with him. I'd never heard of him, but I just thought it was an interesting. These people are incredibly capable people, and they felt like imposters. So why am I going on about this? I've experienced it myself numerous times, especially working at Dave's. I keep getting thrown onto things I know nothing about, and then you got to figure it out. But I'm an expert engineer, so I should be able to do this. Well, yeah, after I learn. And so that's kind of the strategy of working the problem is, number one, start by recognizing that you are not alone in feeling like you're an imposter, especially when you're thrown into something new. Let that energize the learning you need to do in order to be successful. Start asking people who are experienced in the tech stack that you're about to learn, where do I go to learn this? Don't start by saying, tell me everything, but ask them, where do I go to learn this stuff? Because you don't know the difference between a really good info source and a really bad info source, but the experts do. Then, you know, dig in, work the materials, try some things. If there are examples, try those examples. And then that will lead you to questions that have finite answers instead of open-ended. How do I do this? And then then when you're asking questions, a lot of times just writing the questions down will help you find additional space to explore. Now, this is not fake it until you make it. Don't do that. I mean, some people will, but nobody wants to be baffled by BS. They would like you to be authentic, and like Dave will tell you, I'm very authentic about saying I don't know. And teachability is a superpower. Be willing to demonstrate that you don't know something. If you don't know it, other people don't either. And if you ask the question, everybody learns from it. Okay, so all that, and what if I fail? It isn't the end of the world. And if you don't want it to be, it's not the end of your career. I have failed to meet the success criteria of a performance improvement plan. My ears flushed like hot when I wrote that. Even though there was nobody around, I was all alone. I lived. It opened up doors that I couldn't have gone into if I hadn't. Every failure is a learning experience and an opportunity to develop resilience. I'm Phil. You can call me at that number, email me at that address. Thank you.
I'm Will. That's my website. This talk is linking against CMake. And I'm going to preface this and say that I'm not saying that any of this is a good idea, just that you can do it. Okay, so CMake's internals for 30 seconds. CMake actually has an internal library called CMakeLib. The reason for this, it's right there in the CMake list. This is effectively the CMake list of CMake. It's so that both the command line tool and the GUI can use CMake without having to like do syscalls. It's a lot because they list every file out manually. Yes, yes. Okay, so we can link against it. Here's how you do this. I've actually added it with fetch content. I've called it CMake source when I've downloaded it. Why, Chris? Because if you call it CMake, it will create CMake source-dir, which shadows the CMake source-dir variable, which is very important to not shadow. So it's called CMake source. We pull it. I've called this executable loopy. We'll come back to that at the end. Don't worry. And then we link it against right there. We link it against CMakeLib. Now we can use all the functions from CMake from our source code. So now we should be done, right? But CMakeLib actually doesn't have its include directories set up correctly for the target, so you have to add these include directories manually. Okay. Yes. Once you've done that, you can do. I'm going to show you two examples. This first one actually might be useful. The second one is funny. We'll get to it. This one, what am I doing? I'm creating a new CMake list file lexer, and I'm scanning each token. If you look at that while loop inside the Lambda right there, and then I have a function called handle token, which is not important for this talk, but you could do whatever you want with this. You can use CMake's parser, which is actually it's Bison but vendored, and you could make something like a linter. Okay, here's another example. Let's just walk through this, but there's really only 2 important lines. So this is, we have a main function, we create a new CMake object, which that's what the command line tool calls into. We create it in project mode, so we're loading a project rather than just running a script. And then what are we doing on this line here? We're calling run with 3 arguments. We're forwarding our first argv, which is the name of our executable. We're calling -- build, and then dot. What would this do if it was run in our build directory? It would, yeah, it might build itself. Hands up if you think it's actually going to work. I thought that it should. Well, I'll show you what it does. It actually gives us an error message that's probably the understatement of the century. So Linux.
Okay.
It'll do this if you have everything set up correctly. It'll do this anyways. It says it can't find the CMake root because we haven't installed the files to the correct location because nothing's been installed, and it says CMake has most likely not been installed correctly. We did not install CMake, so that is true. All right, that's my talk. Thanks.
All right, I started the timer. I've been working on a tool for the last like 8 weeks, and by saying I actually mean Claude. I haven't written any of the source code at all. I went down quite the rabbit hole. I wanted to tell a story about the evolution of constexpr with array. That was the point. In the process, I ended up developing, well, like I said, Claude did, an entire tool suite that converts the standard to Markdown, which then allows us to do things like look at the differences between different parts of the standard over time. Oh, why doesn't it have the full? Oh no, I didn't deploy the full website. Oh, why not? Wait, oh, oh, so terrible. Oh, curses. All right, well, either way, you can look at the, you can track the changes of the standard by clicking on clicking on the stable names, and you can look at the changes in the standard. Okay, fine, whatever. This is a thing that I ended up doing here, but like 2 days ago, I decided, wouldn't it be cooler if I had an adventure game interface instead? So I asked Claude to write me one. I am on the $100 a month plan right now, $100 a month plan. All right, so yeah, so it just pops you into this like, okay, welcome to Zero Plus Standard Adventure. We are in the intro here, but you can walk around, you can look, and you can go north, and it'll get you to like intro.deps or whatever. But we as one does. You can go to any stable name, and then you can get the complete like. The complete thing of the stable name here, do you have any items? There's no items yet, but there are. Claude understood its mission, so there are NPCs actually, and you can interact with them while browsing through the standard. But anyhow, so we're in the C++ 23 definition of standard array right now. And it wasn't, we need to go back in time to C++ 11. So we can warp back in time to C++ 11 mode. And if you look at standard arrays definition here, you can see that virtually nothing is constexpr, and the things that are constexpr in the way that you would expect them to be. So, for example, size in standard array in C++ 11 is constexpr. What is missing from that declaration? Const. Why is const missing from that declaration? What's that? They forgot. No, they didn't forget. Const is implied for member functions that are constexpr in C++ 11. So that function is const. And in fact, you would have gotten a warning from your compiler that constexpr implied const and that you didn't need to have the const on the end of that. All right, so obviously you can only do const-like things in constexpr in C++11, but there's still things that are missing here. There's absolutely no reason at all that operator paren couldn't have been constexpr in C++11. It could have been. It was const. That would have been fine. They didn't do that. We're going to time travel to C++14. There's a shortcut. I just had Claude add the shortcut for me. And you can see that we have const added to these constexpr things. And now we're in C++14 mode. You can do almost anything in a Turing complete sense in constexpr in C++14. We have for loops and if statements and mutability, right? So why is the non-const operator paren not constexpr in C++14? Because they just didn't do it. They didn't forget. They were like, nobody would need to mutate this thing in a constexpr context. This was an intentional design decision. Data is not constexpr. It could have been. Why? Oh, because they didn't feel like doing it, basically. There's the getters, et cetera, down here. So we get to C++17 mode, and finally, we can do mutable operations at compile time in constexpr. I need to go back one, and I have 15 seconds. No! Anyhow, the short story, I'm out of time, and I'm going to hold myself to it, is that it took from C++11 to C++20 to actually get all these constexpr functions, and they could have been constexpr in 14. That's all. But also adventure game engine. cppevo.dev/adventure if you want to go to it right now.
Gamify the standard.
Yeah.
Is there a leaderboard?
What's that?
Is there a leaderboard? I thought there was XP.
There's XP and stuff, but there's no server state. My time is up.
So did Claude just make this out of whole cloth, or is it using like info?
No, I don't know.
Okay.
I don't know what it is.
Jason's like I told it to do it and I went to bed. You should be a senior manager now.
I have not looked at any of the code. And it is thousands of lines. It's in combination of Lua, Python, JavaScript, CSS. Well, Lua's plugins for Pantalk to do the conversion to Markdown. So that makes sense, actually. They didn't arbitrarily choose Lua. All right, so that's the end of the meetup, right? Does anyone else want to present anything?
No one has any response. Secret lightning talks at the pub now.
Yeah. We're going to the pub. Grab another slice. Who last had pizza? Is there any left out there still?
There's some cheese pizza.
There's some cheese, okay. And maybe some like gluten-free, possibly. All right. So grab some pizza, clean up after yourselves. Thanks for coming. Thanks.